Swayam Prabha. Digital India. Educated India.
Industrial organization is the study of strategic behavior of firms in imperfectly competitive markets. So, there are certainly interesting sort of terms there which we need to focus on. One is strategic behavior, the other is imperfectly competitive markets. So, let us start with the word strategic. So, to understand what the word strategic means, it is useful to understand things which are non-strategic. So, let us step back to our microeconomics course where we learnt about perfect competition, right. So, that was a market structure where nothing was strategic, right. A hallmark of a perfectly competitive firm is that these firms act as price takers, they take the price as given. Prices are set by the market demand and supply and each firm takes that price as given. So, there is nothing strategic about it. We learnt another market structure called monopoly, and even in monopoly there was nothing strategic. There was just one firm and this firm was choosing either the price or the quantity. It did not have to worry about what its other competitors were doing because there were none. So, these were two market structures which we learnt had nothing to do with any strategic behavioral aspect. So, everything between perfect competition and monopoly falls under the realm of imperfect competition. Industrial organization is the study of strategic behavior of firms in imperfectly competitive markets. Let us first make a note of that. So, industrial organization, and we will use IO for it, is the study of strategic behavior of firms in imperfectly competitive markets. There are certain important terms here which we need to focus on. First is strategic behavior and then comes these words imperfectly competitive markets. Okay. So, to understand what we mean by the word strategic, let us first ask what we mean by the word non-strategic. So, if we step back to our microeconomics course, we learnt two market structures. One was perfect competition, the other was monopoly. So, in perfectly competitive markets, the hallmark of a firm was that it was a price taker. So, a perfectly competitive firm did not have the ability to set prices. So, there was nothing strategic about its behavior. So, the price was taken as given, all it had to do was given that price, what quantity should it produce, that was the only decision that it had to take. So, if you look at non-strategic behavior, if you look at behavior which is non-strategic in perfectly competitive markets, in a perfectly competitive market, the firm was a price taker and there was nothing strategic about its behavior. If you look at the other extreme of a perfectly competitive market, which is a monopoly, so the monopolist is the only firm in the market producing a good for which there are no close substitutes. So, if it is the only firm, it does not have to worry about what its competitors are doing because there are none. So, this monopolist was choosing the price or quantity to maximize its profit. Again, there was nothing strategic about it. So, everything in between perfect competition and monopoly comes under the purview of imperfectly competitive markets. So, everything between perfect competition and monopoly also falls under the purview of things that are strategic. So, everything between perfect competition and monopoly, which is the study of imperfectly competitive markets, has aspects of strategic behavior. And it is this strategic behavior that industrial organization strives to focus on. So, the other term that we want to look at is what do we mean by firm behavior, right. So, under firm behavior, what are things that determine firm behavior? So, some things that are captured by firm behavior are obviously the price or quantity that it wants to set. A firm might be interested in knowing what its other competitors are doing, what price and quantity the other competitors are planning to choose, and so what should be the action of the other firms to the actions taken by the other rivals, and so on. So, in this set of lecture, what we will do is we will start with the notion of perfectly competitive market, and thereafter we will get into monopolies. So, let us first look at a schematic structure of various markets that industrial organization is focusing on. So, if I broadly characterize it as perfect competition and imperfect competition, and under perfect competition we already know that firms are price takers. So, P is taken as given. So, the only decision variable is what quantity must the firm decide to produce, and under imperfectly competitive markets we can divide this into monopoly, a duopoly which involves two firms, and more generally an oligopoly which involves more than two firms. So, under a monopoly the firm can either choose to set the price or the quantity, right. So, price or the quantity are the decision variables that the firm can choose to set. And under monopoly there are two types of monopolies that we will study. In one case the monopolist will be charging a uniform price. So, this would be what is called a non-discriminating monopolist. The second type of firm that we will talk about is a firm which will have some ability to charge different prices. So, this would be a discriminating monopoly. And under duopoly and oligopoly, where duopoly has two firms and oligopoly has more than two firms, we will look at again two classifications, one which is behavior captured by non-cooperative actions, and the other one would be cooperative. And under non-cooperative actions, the firms can either move simultaneously or they can move sequentially. So, what do we mean by firms moving simultaneously? When firms are moving simultaneously, they choose either the price or the quantity at the same time, right. So, one firm does not know what the other firm is choosing, and the same thing holds for the other firm. Sequentially means if there are two firms, firm 1 moves first, chooses the price or quantity, firm 2 sees what firm 1 has done and then chooses the price or quantity. And in these models we will talk about cases where the decision variable is either competition in prices or competition in quantities. So, in these two settings we will talk about something called a Cournot market structure, where the firms are choosing quantities either simultaneously or sequentially, and we will also talk about a Bertrand market structure where firms are competing in prices either simultaneously or sequentially. So, let us first start by before we get into the details of oligopoly, let us first start by reviewing and recapping certain basic elements from our perfectly competitive model and also review some aspects of cost functions. So, we will start with perfect competition. So, what are the things or what are the conditions that make a market perfectly competitive? Because we are interested in knowing how do firms choose what quantity to produce when the market structure is perfectly competitive. So, certain conditions for a market to be perfectly competitive are as follows. So, there are many buyers and many sellers. Each of whom is small relative to the size of the market. So, there are many buyers and many sellers. None of these buyers or sellers are dominant firms or dominant buyers, right. So, many buyers and many sellers, each of whom is small relative to the size of the market. All the firms produce identical products. In other words, all the firms produce homogeneous goods. The third condition is that there is full information among all the buyers and the sellers. Fourth, there are no transactions cost. This is also assumed for the market structure to be perfectly competitive. And finally, while we will not be needing it right away, we will get back to it a little while later. There is also a condition that there is free entry of firms into the market and free exit of firms from the market. So, let us focus on the first 4 assumptions. Taken together, these 4 assumptions basically imply that every single firm in this market is a price taker. Why is that so? The fact that there are many sellers, each of whom produce an homogeneous good, essentially tells us that as far as the consumers are concerned, they view the products sold by the firms as perfect substitutes. Right. So, the fact that all of them are producing homogeneous goods and that there is full information essentially implies that as far as the consumer is concerned, the consumer views the products of the firms as perfect substitutes. Moreover, there are no transactions cost, which means that if any one firm tries to raise the price of the product, no consumer will go to that firm and instead will go to some other firm where the consumer is guaranteed to get the product at a lower price. Thus, these 4 assumptions 1 to 4 essentially implies that in a perfectly competitive market, firms are price takers. Which then implies, well, if they are price takers, where do they take that price from? So, you have the market demand and supply structure. So, if this is the demand curve, so I have price and quantity, if this is the market demand curve and if this is the market supply curve, right. The demand curve and the supply curve together tell us that the equilibrium price is P star and the equilibrium quantity traded is Q star. So, this is at the market level, right. So, in the market level, the demand curve and the supply curve are telling us that the equilibrium price is P star. This price is going to be taken as given by each firm in this perfectly competitive market. So, the price P star is taken as given. If I charge a price larger than P star, nobody is going to come to me, right. So, I am not going to see any consumer coming to my firm. There is no incentive for me to charge a price lower than P star, because I can sell whatever units I want to sell at the price P star. So, essentially this firm sees a demand curve which is perfectly elastic, which is perfectly flat. So, while at the market level the demand curve is downward sloping, for a perfectly competitive firm the demand curve that it sees is perfectly flat. What we then want to now ask is, given that the price P star is taken by this firm as given, what Q star should this single firm choose to produce? To answer this question, we need to understand what is the profit of the firm and what quantity maximizes the profit of the firm. So, recall that the profit of a firm, so I will use pi to denote profit. So, the profit of a firm is essentially the total revenue, which is price times Q, and notice P here essentially is set by the market. So, as far as the firm is concerned, it can only choose Q minus the cost. Profit is total revenue minus total cost. So, the firm is choosing the Q to maximize its profit. We will get to that maximization in a few minutes. Let us first focus on what we mean by the term cost. So, the cost C as a function of Q is the sum of the fixed cost and the variable cost. By definition, the fixed cost does not depend on the number of units of output produced. The variable cost of course depends on the number of units of output produced. So, let us first look at what do these cost functions look like. So, if I draw a general cost function, so I have Q on the x axis and I am measuring the total cost in rupees. So, the fixed cost does not depend on the output produced. So, the fixed cost function is essentially a straight line. So, this is the fixed cost. A general variable cost curve. So, given particular functional forms of the variable cost curve, we will be able to draw them exactly, but a typical variable cost curve looks somewhat like this. This is what a typical variable cost curve will look like. So, taken together, the fixed cost and the variable cost curve will then imply that the variable cost curve looks something like this. So, let us understand what is behind this particular shape of this cost curve. So, to get to the cost curve, let us step back and look at a production function for a firm. So, the firm is using let us say labor and capital. So, as I keep changing the amount of labor hired by the firm, the output of the firm, the output or the total product is going to be changing. So, output or total product of the firm is going to be changing, and a general way in which the output or the total product could be changing is a function captured which looks like this, right. So, this is your total product curve. Now, if this is the total product, we know that the marginal product of labor is the change in total product resulting from a change in labor input, keeping capital constant, right. So, to get to the marginal product of labor, we ask, if I change labor by a tiny amount, by how much does my output change? So, essentially if I were to draw tangents at various points to the total product curve, I would get the marginal product of labor. And this marginal product of labor curve would look something like this. This is the marginal product of labor curve. Now, if my so let us focus on the variable cost here, right. So, the labor is the variable input. So, so we have two inputs, let us say labor and capital. Capital is the fixed input and labor is the variable input. So, my cost function can also be written as the fixed cost which is the rental rate of capital, let us call it as R, times the number of units of capital, which is let us say K bar, plus a variable cost which depends on the number of labor units that are hired, and each unit of labor gets paid a wage W. So, let us say the wage rate is W and I multiply that by the number of labor hours, which is dependent on the number of units of output that I want to produce. Now, if I want to find out how the total cost is changing with respect to my output, essentially this is the change in my variable cost with respect to Q, and since the wage rate is a constant number, W times delta L over delta Q, and notice the marginal product of labor essentially is delta Q upon delta L. So, the change in cost with respect to output, so delta C over delta Q is W times 1 divided by delta Q upon delta L, which is W divided by the marginal product of labor, and the change in cost with respect to output is also called the marginal cost. Just as the marginal product is the change in total product resulting from a change in labor input keeping capital constant, the marginal cost is the change in total cost resulting from a change in output. So, that is inversely related to the marginal product of labor. Now, given that the marginal product of labor curve is an inverted U, we can get the marginal cost curve which looks like this. So, the marginal cost curve will be inversely related to the marginal product of labor curve. So, it will have this particular shape, and from the marginal cost we can always go back and derive the cost curve, which is the area under the marginal cost curve. So, that cost curve would look somewhat like this, which is identical to the cost curve that we had drawn earlier. So, to get to the cost curve, we started with the marginal product of labor curve, we used that to get the marginal cost curve, and then we used the marginal cost and went back and derived the cost curve. Okay. Let us spend some more time and look at certain aspects of cost which are interesting. So, in particular we will look at 3 different curves, which is average cost, average variable cost and marginal cost. Okay. Now, since my cost is the fixed cost plus the variable cost, if I divide by Q, my average cost is the average fixed cost. Now, fixed cost does not depend on output, but when I divide it by Q, the average fixed cost depends on the output. So, the variable cost divided by Q is the average variable cost. So, what do these curves look like? So, let us start with the average fixed cost curve. So, since we are measuring the average cost, average fixed cost and the average variable cost, all of those are going to be measured in, let us say, rupees per unit. Right. So, I have a fixed cost and I am dividing it by Q. So, my average fixed cost curve looks somewhat like this. As Q goes to infinity, my average fixed cost tends to 0. What about the average variable cost curve? Well, we already know that this is the variable cost curve. So, if I take the variable cost and divide it by Q, we will get what the average variable cost curve is going to be. So, the average variable cost curve typically will have this shape. The reason it has this U-shaped curve is, recall that recall how output changes as labor changes. So, as I am adding more and more units of labor, output is initially increasing at a much faster rate. The reason being that the fixed unit of capital is being used very efficiently. So, since Q is increasing at a much faster rate compared to the variable cost, the average variable cost is initially falling. Beyond a point, the law of diminishing returns gets applied, wherein output is not increasing at that faster rate at which variable cost is increasing. So, the ratio variable cost by Q starts increasing, and that is why we have the increasing part of the average variable cost curve. Now, notice, since the average cost is the average fixed cost plus the average variable cost, and as Q goes to infinity the average fixed cost goes to 0, that essentially implies that when we draw the average cost curve will tend to the average variable cost curve as Q goes to infinity. So, we have the average fixed cost, the average variable cost and the average cost curve. Let us see how the marginal cost is related to the average variable cost and the average cost curve, which will then complete our entire characterization of the various cost curves. Okay. So, let me again just draw the average variable cost curve here. So, I have a U-shaped average variable cost curve, and recall that my average variable cost is the variable cost divided by Q, okay, variable cost divided by Q. If I want to figure out how the average variable cost is changing with respect to Q, essentially I have, so I use the rule U upon V, which is Q times the derivative of the variable cost with respect to output minus the variable cost times derivative of Q with respect to Q, which is going to be 1, divided by Q square. So, this essentially means that it is Q times the change in the variable cost with respect to output. Now, notice your cost curve is the fixed cost plus the variable cost. So, the change in cost with respect to output, which is also the marginal cost, will be the same as the change in the variable cost with respect to Q. So, because the fixed cost will not change. So, dAVC dQ is Q times the marginal cost minus the variable cost divided by Q square, which on simplification gives us the marginal cost minus the average variable cost divided by Q. So, this is how the average variable cost curve is changing with respect to Q. What this then implies is that in this portion where my average variable cost curve is actually decreasing. So, when my average variable cost curve is decreasing, it essentially means that my marginal cost is less than the average variable cost, right. So, my marginal cost is less than the average variable cost. When dAVC dQ is equal to 0, which is where I am at the lowest point of the average variable cost curve, that essentially means that my marginal cost and average variable cost are equal. And as I move further to the right, when the average variable cost curve is increasing, when dAVC dQ is greater than 0, that essentially then implies that this term here is positive, the MC minus AVC by Q is positive, which implies that the marginal cost is greater than the average variable cost. Now, the same relationship also holds if instead of starting with average variable cost, I started with the variable cost. So, my marginal cost is less than the average variable cost when the average variable cost is falling. My marginal cost is above the average variable cost when the average variable cost is increasing, and my marginal cost is exactly equal to the AVC when AVC is at its lowest point, which essentially means that the marginal cost passes through the lowest point of the average variable cost and analogously the average cost curve. Okay. Right. So, instead of average variable cost, if I just suppress the V, and then take the total cost divided by Q and repeat this entire analysis, we will get exactly an analogous condition where we would say dAC dQ is less than 0 when the marginal cost is less than the average cost. It is equal to 0 when marginal cost is equal to average cost, and it is greater than 0 when the marginal cost is greater than the average cost. So, combined, the marginal cost curve would be something like this. So, it passes through the lowest point of the average variable cost curve, and if I had drawn an average cost curve, it would have also passed through the lowest point of the average cost curve. So, if I just draw an average cost curve here, the marginal cost curve also passes through the lowest point of the average cost curve. So, let us put all of this together and move from a case where capital is fixed. So, all along until now we had one input which was fixed and capital was a fixed input. Now, let us say capital is variable. So, in other words, we move from a scenario where we are in a short run, which is capital is fixed, to a scenario where my inputs are variable. So, as I move from the short run to the long run, so for each level of k, we will have a cost curve, which, and that cost curve essentially would take this particular shape, right. So, now we want to ask, as I keep changing my capital level, as I move from different short runs, what does my long run cost curve look like? What does the long run cost curve look like? To answer this question, let us take 3 levels of capital and then draw 3 different short run cost curves, and we will use those 3 different short run cost curves to get to the long run cost curve. So, let us say my levels of capital are k prime, which is less than k double prime, which is less than k triple prime. So, I have 3 different levels of capital, which essentially implies that for each level of capital I have a fixed cost f prime, which is r times k prime. R is the rental rate of capital. This is less than f double prime, which is equal to r times k double prime, which is less than f triple prime, which is equal to r times k triple prime. Okay. So, let us start with the level where capital is fixed at k prime. So, I have output on the x axis and I am measuring cost, let us say in rupees. Okay. So, when level of capital is k prime, so my fixed cost is r times k prime, and we know that each short run cost curve takes this particular shape in red. So, if I wanted to draw a short run cost curve for a level of capital k prime, that short run cost curve would look something like this. So, we will call it CS depending on the output, but we will say that this corresponds to a level of capital which is k prime. Now, let us move. So, now in the long run capital is variable. So, let us say we move from a level of capital which is k prime to a higher level of capital which is k double prime. At that higher level of capital k double prime, so let us use a different color. So, the fixed cost is r k double prime, and because it is greater than r k prime, the cost curve is going to start at a higher level, okay. And this particular cost curve is going to take this particular shape. So, let me first draw it and then we will ask why it takes that particular shape. Okay. So, in particular, the short run cost curve associated with the level of capital which is k double prime looks somewhat like this. Notice it starts at a higher level, but is a lot flatter than the cost curve in the short run where the level of capital was k prime. And finally, when I move from k double prime to k triple prime, my fixed cost is r k triple prime, but now my cost curve looks somewhat like this, CS q k triple prime. Okay. Now, the thing which is obvious is a higher level of capital implies a higher fixed cost. What is not obvious is why the short run cost curve becomes a lot flatter as the levels of capital keeps increasing. Now, to answer that question, think of what happens when the level of capital increases from k prime to k double prime. So, initially my level of capital was at k prime and it increased to k double prime. Okay. So, the input which is variable in the short run is labor. So, when labor is having more capital to work with, when the level of capital increases, its productivity increases. So, think of a unit of labor which is given multiple machines. So, think of laptops as the machines. So, if I am given multiple laptops, I can multitask and I can produce a lot more goods and services. So, as my level of capital increases from k prime to k double prime, the amount of goods and services produced also increases. In particular, labor becomes more productive, which means the marginal product of labor increases. So, as I move from one short run k prime to the other short run k double prime, the marginal product of labor increases. And recall that marginal cost is inversely related to the marginal product of labor. So, the marginal cost is W divided by MPL. So, my marginal cost is W divided by MPL. So, as I moved from k prime to k double prime, my marginal product of labor increased. So, my marginal cost is actually going to fall. And what is the marginal cost? The marginal cost is the slope of my short run cost curve. Marginal cost is the slope of my cost curve. So, the cost curve associated with a level of capital k double prime is a lot flatter than the cost curve where the level of capital is k prime. And when I move from k prime to k double prime, the marginal product of labor is increasing even more. So, the marginal cost curve is a lot more flatter than the one corresponding to the level of capital which is k double prime. So, we have three different short run cost curves. What is my long run cost curve going to look like? Well, so suppose this intersection point is q prime and let us say that this intersection point is q double prime. Now, in the long run the firm is not constrained, right, by being stuck with a particular level of capital. So, as long as my output is between 0 and q prime, the level of capital that the firm will use is k prime, because that is where the cost is the lowest. So, in the long run for any output between 0 and q prime, the amount of capital that the firm will use is going to be k prime. For output levels between q prime and q double prime, the level of capital that the firm will use, the firm will jump to a level of capital which is k double prime, because that is where the cost is the lowest. So, the level of capital will be k double prime. And finally, for output levels which are larger than q prime, the firm is going to move to a new short run level of capital which is equal to k triple prime. So, for q greater than q double prime, the level of capital that the firm will use in the long run is k triple prime. So, in other words, if instead of 3 discrete levels of capital, if I could change k continuously, then we could argue that the long run cost curve, which is this curve in red, the long run cost curve is the lower envelope of the short run cost curves. So, if I have a series of short runs, I can use those short runs to derive my long run cost curve, and this long run cost curve is the lower envelope of the short run cost curve. Now, let us with this idea of cost, of both the short run cost, the average cost, average variable cost and the marginal cost, as well as the notion of what a long run cost means, let us go back to our question of what is the profit maximizing output of a perfectly competitive firm, and recall that the profit of the firm was price times quantity minus the cost. So, in the short run this cost would be the short run cost. So, the firm, so the perfectly competitive firm is taking the price. So, I will just write this as rupees per unit. The price P star is set by the market. So, the firm is choosing the Q to maximize its profit. So, the derivative of the profit function with respect to Q is going to give me P minus dC dQ, which is essentially P minus the marginal cost, right. And a necessary condition for the Q to be maximizing the profit is that this derivative be equal to 0. So, necessarily the output Q star is obtained from the condition that the price, which is P star, must be equal to the marginal cost, right. So, the price P star must be equal to the marginal cost. Now, if my marginal cost curve looks like this, if this is my marginal cost curve, the marginal cost curve intersects the P star line at two different points. So, which Q star should the firm choose? So, for this, if we look at the second order condition for profit maximization, we will have minus of the derivative of marginal cost with respect to Q. This should be necessarily less than 0, which implies that the marginal cost curve must be upward sloping. This implies that the Q star that the firm is going to be choosing must be a Q star which is associated with the upward sloping portion of the marginal cost curve. Okay. Let us take an example and figure out, if our data is in discrete terms, how do we figure out what is the optimal quantity that a firm should produce in the short run, and thereby we will try and figure out what is the supply curve of a perfectly competitive firm. So, let us take an example. So, if we look at this example, notice here we are given the output produced by the firm, which varies in steps of 1 from 1 till 14, and the corresponding variable cost is also given. So, think of a firm operating in the short run where labor is the variable input, capital is the fixed input, and as the firm keeps adding more and more labor inputs to the plant, the variable cost component changes, and this is how it changes. Also suppose that the fixed cost is constant at 20. So, imagine that there are 2 machines and the rental rate per machine is 10 rupees per machine. So, the fixed cost is 20. So, once the variable cost and the fixed cost are known, I can compute what the total cost is. So, the total cost essentially is the sum of the variable cost, which is 15, plus the fixed cost, which is 20, and we can compute this entire table. We also compute what the marginal cost is. What is the marginal cost? The marginal cost is the change in total cost resulting from a change in output produced. So, if I produce one more unit of output, so when I was not producing at all, the total cost was 20, the fixed cost was 20. For when I produced 1 unit, the total cost increased to 35. So, the marginal cost is 35 minus 20, which is 15 rupees per unit. Similarly, the marginal cost of producing the second unit is 47 minus 35, the total cost of producing 2 units minus the total cost of producing 1 unit, which is 12 rupees per unit. And similarly, we can compute the marginal cost for any unit of output that the firm is producing. And notice the marginal cost has this U-shaped curve. The marginal cost is decreasing, reaches its lowest point, and then it starts increasing. Okay. We will come to these columns in just a moment. Suppose that the price P star is equal to 12. So, the price P star is obtained from the market demand and the market supply curve. If the price is P star, which is 12, what quantity should the firm produce? Well, we saw that the profit maximizing condition for a firm is that the optimal quantity Q star must satisfy the condition price is equal to marginal cost. So, if I apply that same rule, if we apply that same rule, price equals marginal cost when the price is 12 rupees per unit. This is my marginal cost column. Notice that to produce the 10th unit of output, the marginal cost is 11 rupees per unit. The marginal cost is less than the price. So, if the firm were to sell the 10th unit, it would get 12 rupees, but the extra cost that it would incur in producing that unit would be 11. So, it still makes sense for the firm to produce that unit, but for the 11th unit of output, the marginal cost is 14, which is larger than the price of 12 rupees per unit. So, the firm using the rule price is equal to the marginal cost, it is not exactly equal because the data is discrete. The firm is going to stop by where it produces 10 units. So, in the context of P star equal to marginal cost, when the price P star is equal to rupees 12 per unit, when the price P star is rupees 12 per unit, the optimal quantity produced by the firm Q star is actually 11 units, or rather 10 units. The firm produces 10 units, the Q star is 10 units. And what is the profit that the firm gets? The profit that the firm gets is the total revenue minus the total cost. Well, the total revenue is 12 times 10, which is 120, and the total cost is 107. So, the total revenue minus the total cost is the profit, which is equal to 13 rupees. So, the profit is positive, which is nice for the firm. So, the profit that the firm gets is 13. Okay. So, let us ask, under what conditions is the profit of the firm going to be positive? So, if I have the general cost function, which is total revenue minus total cost. So, if I write down the profit as the total revenue minus the total cost, when will the profit be strictly positive? Well, the profit will be strictly positive when the total revenue minus total cost is greater than 0, which is to say that the total revenue is greater than the total cost, right. And notice that this firm takes the price as given. So, essentially the price is P star. So, this essentially means that my P star times Q is greater than total cost. So, P star must be greater than the total cost divided by Q, or P star must be greater than the average cost. So, if you look at an average cost curve, what does it mean to say that P star must be greater than the average cost? Well, the profit is going to be positive when this condition is satisfied. If P star is less than the smallest of the average cost, if P star is less than the smallest of the average cost, then it will never satisfy this condition. P star is greater than the average cost. So, it will never satisfy this condition. In other words, the firm's profit is always going to be positive as long as P star is greater than the average cost. If P star is less than the minimum average cost, the firm's profit is going to be negative. Okay. We'll keep this in mind because it's going to tell us something useful. Let's go back to that example. So, now instead of a price of 12, if I take a price which is equal to, let us say, 8 rupees per unit. Okay. Now, notice that the minimum average cost, so we have a column J where the average cost also is computed. How did we get this average cost? We had the total cost divided by Q gave us the average cost. The lowest average cost or the minimum average cost is 10.67, the price is greater than 10.67, which says that the profit is going to be positive, which is what we found. The profit was indeed positive, which is equal to 13 rupees. Now, if I take a price, so let us say the price P star. So, what is it that we are trying to do? We are saying that for different prices that are set by the market, what is the output that this competitive firm is going to be producing? In other words, we want to get some sense of what the supply curve of this perfectly competitive firm is going to be. So, suppose the price P star was rupees 8 per unit. Suppose the price P star was rupees 8 per unit. Now, if I simply use the same rule, P star is equal to the marginal cost, all I would need to do is to go to the marginal cost column. All I would need to do is to go to the marginal cost column and find out where the price which is equal to 8. So, let us make this 8, where the price is equal to 8 would be equal to the marginal cost. And if I were to do that, notice the following. So, the marginal cost column stays the same. Well, for the 8th unit, the marginal cost is 7, my price is 8 rupees per unit. So, the firm should produce the 8th unit, but the moment I move to the 9th unit, the marginal cost becomes 9 rupees per unit, which is greater than the price. So, as per the rule price equals marginal cost, the firm should stop at Q equal to 8. So, let us make a note of it. So, using the rule price equals marginal cost, the firm should be producing 8 units. Let us check what the profit is going to be. So, the profit here when the firm was producing 8 units was the total revenue, which is 8 times 8, which is 64, minus the total cost, which is 87, and that turns out to be 64 minus 87, which is minus 23. So, the profit of the firm total revenue minus total cost is minus 23, which is less than 0. Okay. Now, the profit is going to be negative was anticipated, because we just learnt earlier that if the price is greater than the minimum average cost, the firm's profit is going to be positive. The minimum average cost was 10.67, the price is 8. So, clearly price is not greater than the minimum average cost. So, the profit is going to be negative. So, that is not surprising. But notice we need to be a little bit careful in using this rule price equals marginal cost. Now, the firm is in the short run. So, it is stuck with a level of capital which it can't get rid of. So, in other words, the fixed cost of 20 is going to be incurred by the firm no matter what. Now, if the firm decided, so let us ask, can the firm do better than what it currently is doing? So, currently the firm is incurring a loss of 23. Can the firm do better, which means can the firm reduce its loss? What if the firm decided to not produce at all? What if Q was equal to 0? In that case, the profit of the firm would simply be the total revenue, which is 0 because I am not producing, minus the variable cost, which is again 0 because I am not producing, but now the fixed cost of 20 stays. So, if the firm decided not to produce at all, the firm's profit would be minus 20, which means it would have a loss of 20. Now, clearly using 20 is better than losing 23. So, when the price is 8 rupees per unit, the optimal choice of the firm is actually Q equal to 0, which is to not produce at all and not choose 8 units of output, which we incorrectly computed by using the rule price equals marginal cost. So, let us ask, under what condition can I use the rule price equals marginal cost, and under what condition will the firm not produce at all? So, a profit maximizing firm will choose to produce something positive, will choose to produce a positive quantity of output if and only if the profit that it gets by producing those units of output is at least as large as the profit that it gets by not producing at all, right. So, if by producing some positive quantity of output my profit turns out to be lower than the profit that I would get by not producing at all, then why should the firm produce? Now, let us do a little bit of algebra. So, this means the total revenue minus the variable cost minus the fixed cost, I am suppressing the Q for total revenue and variable cost, is greater than or equal to the profit that the firm gets when Q is 0. Well, when Q is 0, the profit is essentially the fixed cost. I can get rid of the fixed cost from both sides, and I can rewrite this as total revenue greater than or equal to variable cost, and the total revenue is the price times quantity. So, price times quantity is greater than or equal to the variable cost, and since Q is greater than 0, if we divide by Q on both sides, I will have P greater than or equal to variable cost divided by Q, which is equal to the AVC. So, if my price is greater than or equal to the AVC, then I have that the firm will produce something positive. Now, since the average variable cost itself is a U-shaped curve, what does it mean to say that the price is greater than the AVC? Well, if I have a price which is less than the smallest average variable cost. So, I have a U-shaped average variable cost curve. I have a U-shaped average variable cost curve. If my minimum average variable cost is here and my price turns out to be smaller than this lowest average variable cost, then it will never ever be larger than any other average variable cost, which means it will not satisfy this condition, which means it will not satisfy this condition, which essentially means that the firm should not produce, which means that the firm should shut down. Now, if you go back to our example, this is exactly what is happening. Let us compute what the average variable cost is. Let us compute what the average variable cost is. So, the average variable cost is the variable cost divided by the output. So, the average variable cost again takes this U-shaped curve. The lowest average variable cost, which is the minimum average variable cost, is 8.375, and notice that my price is smaller than this minimum average variable cost. So, the firm should indeed shut down. The best that it can do is produce Q equal to 0 and incur a loss of 20. Finally, let us take a price which is in between the minimum AVC and the minimum average cost. So, let us take a price which is equal to 10 and see what happens. If I take a price which is equal to 10, if I take a price P star which is equal to rupees 10 per unit, notice this price is greater than the minimum average variable cost. So, it tells us that the firm will produce. The question is how many units will it produce? Now, given that we have sort of figured out that it will necessarily produce, the optimal quantity Q star that the firm will produce will always be obtained by comparing now the price with the marginal cost, right. So, the rule that we had earlier by comparing the price with the marginal cost applies once we have figured out that the price is greater than the minimum average variable cost. So, if we look at the table for marginal cost, my price is 10. For the 9th unit, the marginal cost is rupees 9 per unit. For the 10th unit, the marginal cost is 11 rupees per unit. So, the firm is going to stop at Q star is equal to 9 and will incur a loss of 6. Why 6? Because the revenue will be 10 times 9, which is 90, minus the total cost, which is 96. So, its profit is going to be minus 6. So, the firm's profit, the firm will choose to produce Q star equal to 9 units. Its profit is going to be negative, but notice that the firm's profit is negative, still it continues to produce, because if it were to shut down, it would lose even more, because if it were to shut down, its loss would be 20. By producing 9 units, its profit is minus 6, which is better than what it would get by shutting down. So, for any price between the minimum AVC and the minimum AC, the firm will always produce, but its profit is going to be less than 0.